Welcome back to my channel Techno Education Academy. In this video lecture, we will discuss about resultant force and parallelogram law of forces. From this theorem, we will derive the equation of resultant. Let's start. First of all, what is resultant? It is defined as the single force capable of producing the same effect on a body as that of a given system of forces acting on a body. Here you can see that here we are considering the four forces P1, P2, P3 and P4 are acting simultaneously on a particle. It is possible to find out a single force which could be replaced by the combined effect of all forces, which would produce the same effect as produced by all the given forces. What is equilibrium force? To balance the resultant force, a force of same magnitude but in opposite direction is required. This opposite balancing force is called equilibrium force. Here you can see that in schematic diagram, R is the resultant force and in opposite direction, okay, with the same magnitude but in opposite direction, the equilibrium force, it is represented by R dash. Now we will derive the equation of resultant from the law of parallelogram. Okay, what is the statement of parallelogram law of forces? It states that if two forces acting simultaneously on a particle be represented in magnitude and direction by the two adjacent sides of a parallelogram, their resultant may be represented in magnitude and direction by the diagonal of the parallelogram which passes through their point of intersection. Here you can see that here we are considering two vector forces P and Q which meet at point O, okay, and their resultant is R. It will pass through the diagonal of the parallelogram. Here R is the resultant force, theta is the angle between P and Q force, and alpha is the angle between P and R, one force and resultant. From the triangle ODC, according to the Pythagoras law, OC square equal to OD square plus BC square. But we know that OD equal to OA plus AD. Now we will put the value OD equal to OA plus AD. So now we will put the value of OC equal to R, OA equal to P, AD equal to Q cos theta. Here you can see that which term it's making an angle with the reference line. This term is called cos term and the remaining term is called sin term. So this is Q, OB equal to Q, so AC equal to also Q, and Q which makes the angle with AD, reference line. So this term is called Q cos theta and the remaining term is called Q sin theta. So AD equal to Q cos theta and DC equal to Q sin theta. Now we will put the value of OC, OA, AD and DC in equation of OC square. So now we will put the value OC equal to R. So R square equal to, we know that according to the fundamental of mathematics, x plus y square equal to x square plus 2xy plus y square. So here P square 2pq cos theta plus q square cos square theta plus q square sin square theta. But we know that sin square theta plus cos square theta equal to 1, and here q square term is common, so it is keep it outside from the bracket and put the value cos square theta plus sin square theta equal to 1. So the equation of resultant force R square equal to P square plus q square 2pq cos theta. Further we simplified this equation. So this is the equation of R square. So R equal to under root sine of P square plus Q square plus 2pq cos theta. This is the equation of resultant. Okay, whenever the two forces are given, okay, and it will intersect at point O and its resultant, it will pass through the diagonal of the parallelogram. The angle alpha which the resultant makes with P can be obtained as, okay, here we are using the fundamental of trigonometry. So tan alpha equal to in front side upon near side. So in front side is CD and near side is OD. Now we will put the value of OD equal to OA plus AD. Further, we simplified this equation by putting the values of CD, OA and AD in this equation. CD equal to, we know that, Q sin theta. OA equal to P, and AD equal to Q cos theta. So this is the equation of alpha, tan alpha, and from this equation we can calculate the angle. Okay, in between, it is the angle between the P and R. From this equation we can calculate alpha, and it is the angle between the P and R. Let's solve one example. Two tensile forces 50 kilonewton and 40 kilonewton acting at a point with angle 60 degree between them. Find magnitude and direction of the resultant. Here the two forces is given, 40 kilonewton and 50 kilonewton. Its angle is 60 degree, and alpha is unknown and R is also unknown. So here P equal to 50 kilonewton is given from the data, and Q is also given 40 kilonewton and theta equal to 60 degree. We know that the equation of resultant R equal to under root sine of P square plus Q square plus 2PQ cos theta. We have already derived it in previous slide. Now we will put the value of P, Q and theta in this equation. So further we simplified this equation. P equal to 50 kilonewton it is given, Q equal to 40 kilonewton is given, okay, and theta equal to 60 degree. So R equal to under root 60 100. So R equal to 78.10 kilonewton. So from the equation of tan alpha, we can calculate the alpha. Tan alpha equal to Q sin theta upon P plus Q cos theta. We have already derived it in previous slide. We will put the value of P and Q in this equation, and we can calculate the value of tan alpha. So tan alpha equal to 0.495, and alpha equal to tan inverse 0.49. So alpha equal to 26.33. Okay, it is the angle between R and P. So thank you friends for watching this video. I hope this content it will be helpful to you. If you would like to watch this type of more technical videos, then please subscribe our channel and also press bell icon for more video updates.